Colorimetric analysis is a method of determining the concentration of a chemical element or chemical compound in a solution with the aid of a color reagent. It is applicable to both organic compounds and inorganic compounds and may be used with or without an enzymatic stage. The method is widely used in medical laboratories and for industrial purposes, e.g., the analysis of water samples in connection with industrial water treatment equipment. The equipment required is a colorimeter, some cuvettes and a suitable color reagent. The process may be automated, e.g., by the use of an autoanalyzer or by flow injection analysis. Recently, colorimetric analyses developed for colorimeters have been adapted for use with plate readers to speed up analysis and reduce the waste stream. Non-enzymatic methods. Examples: calcium plus ocre phthalate complex zone to colored complex. Copper plus bathocuprone disulfonate to colored complex. Creatinine plus picrate to colored complex. Iron plus bathophenanthroline disulfonate to colored complex. Phosphate, inorganic, phosphate plus ammonium molybdate plus ammonium metavanadate to colored complex. Enzymatic methods. In enzymatic analysis, which is widely used in medical laboratories, the color reaction is preceded by a reaction catalyzed by an enzyme. As the enzyme is specific to a particular substrate, more accurate results can be obtained. Enzymatic analysis is always carried out in a buffer solution at a specified temperature, usually 37 degrees Celsius, to provide the optimum conditions for the enzymes to act. Examples follow. Examples: cholesterol, Chod-Pap method, cholesterol plus oxygen, enzyme cholesterol oxidase, to cholesterol plus hydrogen peroxide plus 4-aminophenazone plus phenol, enzyme peroxidase, to colored complex plus water, glucose, Godperid method, glucose plus oxygen plus water, enzyme glucose oxidase, to gluconate plus hydrogen peroxide plus ABTS, enzyme peroxidase, to colored complex. In this case, both stages of the reaction are catalyzed by enzymes. Triglycerides, GPO-PAP method, triglycerides plus water, enzyme esterase, to glycerol plus carboxylic acid, glycerol plus ATP, enzyme glycerol kinase, to glycerol 3-phosphate plus ADP, glycerol 3-phosphate plus oxygen, enzyme glycerol 3-phosphate oxidase, to dihydroxyacetone phosphate plus hydrogen peroxide plus 4-aminophenazone plus 4-chlorophenol, enzyme peroxidase, to colored complex. Urea plus water, enzyme urease, to ammonium carbonate plus phenol plus hypochlorite, to colored complex. In this case, only the first stage of the reaction is catalyzed by an enzyme. The second stage is non-enzymatic. Abbreviations: CHOD equals cholesterol oxidase, GOD equals glucose oxidase, GPO equals glycerol 3-phosphate oxidase, PAP equals phenol plus aminophenazone. In some methods the phenol is replaced by 4-chlorophenol, which is less toxic. Perid equals peroxidase. Ultraviolet methods. In ultraviolet UV methods there is no visible color change, but the principle is exactly the same, i.e., the measurement of a change in the absorbance of the solution. UV methods usually measure the difference in absorbance at 340 nanometers wavelength between nicotinamide, adenine dinucleotide, NAD, and its reduced form, NADH. Examples: pyruvate Pyruvate plus NADH. Enzyme lactate dehydrogenase. 2L-lactate plus NAD. See also. Blood sugar. MBAS assay. An assay that indicates anionic surfactants in water with a bluing reaction. Nessler cylinder.